All right, for the last part of notes 2 here, we're going to do multiples, factors, least common multiple, and greatest common factor. So problem number 7, there's, 4 parts to this? Yes. And we're looking at multiples. So multiples, what you're thinking about or what you should be thinking about is when you were in grade school, whatever, your teacher would ask you to count by fives. That's what multiples are. Counting by twos, counting by fours, counting by fives. In case of part D, it's going to be counting by sevens. So if we start with part A here, counting by twos, 2, 4, 6, 8. There's 4 multiples of 2. If I move on to part B, counting by fours, 4, 8, 12, 16. One that we have all probably done lots of times, which is count by fives. So that's going to be 5, 10, 15, and 20. Now, these lists don't end after these fourth numbers I'm writing down. The reason I'm stopping at 4 is simply because the directions say to list 4. There's an infinite number of multiples for every number. Last but not least in the set of multiples is going to be part D here, which is count by sevens. So 7, 14, 21, and then 28. So that's multiples. You're counting by that number. You could also do whatever the number is times 1, times 2, times 3, times 4, which is how I'm getting each one of these lists. So 5 times 1, 5 times 2, 5 times 3, 5 times 4. And you can keep then going to get more multiples. Okay, so those are multiples. Let's now slide over and change things for number 8 here, which is to write factors. Factors are the numbers that can divide into your given number. So oftentimes if you want to talk about, I'll use, first problem here as an example, what two numbers or what numbers divide into 12 is one way you can look at it. Or you can think about pairs of numbers that multiply together to get you 12. So I always start with the number 1 and the initial number that I'm looking for. So 1 times 12. I'm going to work my way up the number line. So 1, 2, well, that would be 2 times 6 gets me 12. Keep working my way up. 3 times 4 gets me 12. Now, you'll notice this list goes 1, 2, 3. The next number in the list would be the number 4 here, but 4 is already part of my list over here. These numbers are all of the factors of 12. There are no more. So I can do the same thing now for the rest of this set of examples here. So part B, so there's going to be 20, so there's going to be 1 times 20. How about 2 times 10? 3 doesn't go into 20. 4 goes into 20, so 4 times 5. And same thing, 5 would be the next number on the list, but 5 is already here. So that's the exhaustive list. That's all of the things that are pairs of numbers that can get you 20. So let's see, 24 is part C here. So again, I start with 1 times 24. Let's see, 2 times 12. 3 times 8, 4 times 6. 5 doesn't go into 24, and 6 is already on my list. So there is the set of 4 pairs of numbers for a total of 8 factors for 24. Last but not least here is part D, which is 32. So we're going to do 1 times 32. 2 times, that is a horrible 16 there. There we go. 2 times 16. 3 does not go into 32. 4 does go into 32. It's going to be 4 times 8. 5 does not go in. 6 doesn't go in. 7 certainly does not go in. And 8 is already on my list. So these 3 pairs are the values that will get me, these 3 pairs of factors will get me 32 when I multiply them together. All right, so that's, be careful with the difference between factors. Factors are things that multiply to get the number you're looking for. So 2 times 6 gets you 12. 2 and 6 are factors. Multiples are when you're counting by that number. So again, 5, 10, 15, 20. 5 is a multiple of 5. 10, 15, and 20 are all multiples of 5. All right, so problem number 9, I'm going to show you a couple different ways to find an LCM, a least common multiple. All right, and some of these are going to be easier than others. I'm going to be honest, you pick the method that you like and you stick with it. I don't care your method. So for part A, I am going to list out the multiples of 3 and 5 and find the smallest multiple that they have in common. So for 3, I'm going to start counting by threes. 3, 6, 9, 12. Get that 12 actually in there. 15, 18, 21, and I'll see if I need more, then I can add more. All right, for 5, 10, 15. Now, I could keep going, but I'm not going to. And the reason I'm not going to is because I can already see that 15 is in both of my lists. So what is the least common multiple, the smallest, least common multiple between 3 and 5? That is the number 15. Okay, I'm going to do the same method for problem part B here, which is, right, least common multiple for 2 and 9. I'm going to count by 2s, count by 9s. So 2, 4, 6, 8, 10, 12, 14. Whoops, that is a horrible 16, 18, 20, 22. If I need more, I can add more. All right, I'm going to count by 9s. 9, 18, and at that point, I'm just going to stop. The reason, again, I'm stopping is because I say easily, but there's my 18 in that list, there's my 18 in that list. And while 9 is also a smaller number, there is no 9 in the multiples of 2. So what is the least common multiple for 2 and 9? That is going to be the number 18. Now, if you're looking at this going, do you have a different method? The answer is yes, I do. So let's take a look and see if I can do problem number 4, part C, which has a 4 in it, differently. So for part C here, what I'm going to do is look to see if I can do what's called a factor tree for 4 and then a factor tree for 12. Now, what's a factor tree? Tell me numbers that multiply to 4. Well, 2 and 2. 2 is a prime number. 2 is a prime number. Now, prime numbers, you might be thinking, well, what's a prime number? So when I asked what multiplies to 4, you can tell me 2 numbers that multiply to 4. If I ask you what multiplies to 2, the only thing that you could branch off of here would be 2. That's a horrible 2 and a 1. But you just had a 2. Why would I repeat that? So when you get to the point where the only number is a prime number, right? Prime numbers are only multiplied with 3 and the number itself. That's the only way you can create them. So 4 is the same thing as 2 times 2. Okay. Now for 12, we're going to do the same kind of factor tree. Anything that multiplies to 12 is how you want to break it. It won't matter. You might say, well, I'm going to do 3 times 4 and somebody else does 6 times 2. Doesn't matter because you're going to keep going until you get prime numbers. So for 12, let's say I do 2 times 6. All right, I can't break up a 2, so I'm going to circle it up, but I can break up a 6. That's 2 times 3. Well, I already know 2 is a prime number. If I try and branch off of 3, that would be 3 and 1. That's not helpful. So I'm going to go ahead and delete that. All right, so prime number here, which means for 12, 12 is equal to 2 times 2 times 3. Now, how do I find an LCM out of this? Well, what I look for is each one of the individual numbers that's involved here, and meaning factors. Okay, so each one of these individual factors here. And what I need to do is include it the maximum number of times. So what on earth is going on here? So I have 2's. The maximum number of 2's that I have in either number is 2 2's. So for my LCM, I'm going to have 2 2's. And I have a 3 here as a factor, just one of them, so I need to include that. 2 times 2 times 3 is 12. The least common multiple for 4 and 12 is 12. So I'm going to keep using this method with factor trees for part D, 6 and 8. All right, so for 6, if I break this up, that's 2 times 3, prime number, prime number. All right, so 6 equals 2 times 3. All right, for 8, I can do 2 times 4. 2 is a prime number. 4 gets broken up into 2 and 2. So for 8, I have 2 times 2 times 2. So a total of 1, 2, 3 2s. There's my 3 2s. So my LCM, my least common multiple, has to have a 2, at least, right? Some form of a 2 and some form of a 3. So how many 2s do I need? Well, 6 only has 1 2, but 8 has 3 of them. That means I need all 3 of them. So 2 times 2 times 2. And I need the 3, just one of them, that comes out of the 6. So 2 times 2 is 4, times 2 is 8, 8 times 3 makes 24 is the least common multiple of 6 and 8. Okay. All right, last one. What happens if you're dealing with 3 numbers? Well, you do the same thing you've been doing. Either list out your multiples. So count by 2s, count by 3s, count by 5s. Find the one number, the smallest number that's in both or all 3 lists. But you can also do your prime factors, right? Your factor trees. Now, the fun part about 2, 3, and 5 is, well, 2 is a prime number. 3 is a prime number, and 5 is a prime number. So what that means for me is the only way, 2 doesn't get broken down, 3 doesn't get broken down, 5 doesn't get broken down. So for my LCM, my least common multiple, I need a single 2, a single 3, and a single 5. So 2 times 3 makes 6, 6 times 5 makes a least common multiple of 30. So least common multiple, this is the smallest number that 2, 3, and 5 will all divide into. So 2 goes into 30, 3 goes into 30, and of course 5 goes into 30. Okay, that's least common multiple. Last set here is greatest common factor, GCF. And let's talk about how we can find a GCF. And the thing is, I'm actually going to use pretty much the same method I was using with those factor trees. Now, again, I'm going to show you a couple of methods. You pick the one that you like. So for the first one, all right, so for problem part A here, I'm going to list out the factors of 4. So 1 times 4 and 2 times 2. That's it. Nothing else is going to work. For 10, I've got 1 times 10, 2 times 5. Nothing else is going to work. For a greatest common factor, what I want is the largest number that shows up in both of those lists. So the largest number overall is 10, but 10 doesn't show up as a factor of 4. Then we've got 5, but again, 5 is not a factor of 4. 4, but 4 is not a factor of 10, right? The only thing that they have in common is 1, right? 1 is in both of our lists, fabulous, but that's not the largest or the greatest common factor. There are a common factor of 2. That's the GCF. GCF, right? Greatest common factor, the largest number that will divide into 4 and into 10. All right. Part B, I can do the same thing, right? 1 times 6, 2 times 3 for my factors of 6. 9, 1 times 9, and 3 times 3. What do they have in common? Well, they have a lovely 3 in common. All right, 3 here and the 3 here. That's all that they have in common. Cannot do anything else. All right. Now I'm going to change it up and I'm going to basically do the factor trees. Now, if you're good with writing out the lists of factors and matching it up that way, great, do that. But I'm going to show you a different method in case you're going, I don't like that. Pick your method. So if I do factor trees for 10 and 25, okay, so for 10, this would break up as 2 times 5. All right, so 10 is going to be 2 times 5. And for 25, that would break up as 5 times 5. So 25 is 5 times 5. And it's not necessarily what's the largest number. It's you got to look at all the factors combined. So when I look at 10, 10 is a factor of 2, but 25 does not. They both have factors of 5. 10 has a single factor, 25 has 2. You only pick the smaller number this time. So a single 5 is what you would be able to factor out of both of those, right? Greatest common factor. All right, keep it moving on along here. Let's do pair 8 and 20. Greatest common factor. So let's see, 8 can be broken up as 2 times 4. 4 can be broken up as 2 times 2. So 8 is 2, 2, and 2. All right, 20. We've got 2. That's a horrible 2, but 2 times 10. Hold on a second. Let me do a quick erase job on that. There we go. 2 times 10. 2 is my prime. 10 is 2 times 5. So 2 and 5. So that means for 20, I've got 2, 2, and 5. All right, so by looking at my factors here, I can see that, yes, we share some factors of 2. I do not need to worry about the 5 at all because that is not a shared factor. But how many 2's do they share? Well, 20's got 2's, two 2's, and I can grab 2 of the 2's, 2 factors here and here that match up. So as far as my GCF goes, 2 times 2 makes a GCF of 4. So the common factor that they have there. So yes, there is an extra 2 here, but 20 doesn't have that third 2. There's a 5 here. 8 definitely doesn't have a factor of 5 in it. All right, last one for this video, and that's going to be what happens with 12 and 32. So let's break these down. So for 12, let's say I do 3 times 4. 3 is prime. 2 times 2 for 4. So for 12, we have 2, 2, and 3. For 32, let's say I do 8 times 4. Well, 4 is going to be 2 and 2. 8 would need to be 4 times 2. And there's another 2 and another 2. So a grand total of 1, 2, 3, 4, 5 2's. Make sure I write them all down here. So 32, 2, 2, 2, 2, and 2. All right, cool. So what do they have in common? Definitely they share some 2's in common. So let's see, we've got a 2 here and a 2 here, a 2 here and a 2 here, and I've now run out of things that they have in common. So unfortunately, even though there's a whole bunch of extra 2's here, as far as the greatest common, that common piece is important, they no longer have any more 2's in common. So 2 times 2 makes a grand total of a GCF of 4. All right, so please be careful understanding the difference between greatest common factor, right? What can divide into your given numbers here versus least common multiple, which is a value that your numbers can divide into. Please let me know if you have any questions or concerns.